So here we are in parabola. I've got this point and I've got this line. And I want to find another point that is halfway between the directrix line and the focus point. Can you tell me a point that is equidistant, same distance from the focus point and the directrix line? So what's a point that is same distance from?
Would be y.
Yeah, I could tell, Becca, you're pointing right there, right?
Yeah.
And that's perfect. Yes. That's right, right? That's a point that's right smack in the middle, right? In other words, his distance from the focus, his distance from the directrix line are equal, equidistant, right in the middle of the point and the line. Good so far? That's one dot. I want to get some more. That's one dot. The parabola is all the dots. That's what a parabola is. The parabola, let me just write it down. What is a parabola? How'd they come up with this curvature? It's all dots that are same. Again, this is not required. You can just watch this if you want. I just want to show you where it comes from. It is all dots that are same distance. That says distance. That are same distance from the focus point and that line called the directrix line. It's the set of all points. Every dot. If you put together all the dots that are same distance from the focus point of the directrix line, that's going to be your parabola. Well, what do we mean? Now, you might think, well, what do you mean, Mr. Aaron? It's just going to be a straight line. It's just going to be like all these dots, straight up and straight down. It's just going to be, that's just a line. It's not a parabola. No, that's actually not right. But it's a natural thought. Let me explain why that's not the truth. Let's take a look at this point, for example. Is it true that he is the same distance, this point right here, is he the same, how far is he from the focus point? That's how far he is from the focus point. How far is he from the line? Only that far away. So he is not the same distance from the line as he is from the focus point. So he's not on the parabola. The parabola is all the dots that are the same distance. So do you see what he needs to do? He needs to move a little bit further to the right, like right here. Then he would be same distance from those two things. Maybe I went a little too far. Maybe move him back about right. Maybe right about there. That right? If you put him there, then he would be right about same distance from the line and the focus point. Don't you think? That looks about the middle. That dot there looks like he's equidistant, same distance from the focus point. Do you get the idea? It's going to be all the dots along this. It's going to be a parabola. See, all the dots on that parabola are same distance from the focus point and the directrix line. That's what a parabola is, the set of all dots that are the same distance between a line and a point. And that curvature that's created by that rule turns out to be very useful curvature for many real-life applications. Okay, so that's the theory, not required. From that comes these special formulas. I don't have time to derive it. It's not that hard. It only takes about 10, 15 minutes. Be glad to do it in office hours with you. I love to do that kind of thing. But I don't want to use up class time because it's not required and we have limited time. So what I'm going to do is I'm just going to write the results for you. So here's the results. We basically end up with 4 different directions on the parabola, up, down, right, or left. So the parabola can be going up. The parabola can be going down. The parabola can be going right. And the parabola can be going left. It's all about there. Now the direction is determined. Well, let me do the focus point first off. The focus point is at A. We call it A. I don't know why. But it's always inside the satellite dish. So the focus point is always inside the satellite dish. And the directrix line is behind the satellite dish. Like the thing we just made up, right? The way we just defined it. The directrix, it's a dotted line because it's not actually part of the graph. It's just behind the parabola. Okay, now the equations, here's the part you want to really hone in on is the equations. The direction of the parabola tells the right side first power letter in the equation. What do I mean? Look at that first one. It's going up. That's the positive y direction, right? So the right side is going to be positive 4ay. Where'd the 4 come from? It's all part of the derivation. I didn't show it. Want to see it? Come to office hours. But all you need to know is it's positive 4ay. So the other side is the other letter, so that must be x squared. But the right side tells the direction. So on the next one, what's the direction of the second one? Negative y, down, huh? So the right side is going to be what? Negative 4ay. It's negative y, down. The other side, it's got to be x squared. Let's do the third one. The third one, what direction is that third one going? To the right. Positive x. So what's the right side going to be?
4ax.
Positive 4ax. The right side tells the direction. The other side is the other letter, so it had to be y squared. The other side is squared, notice, and it's the other letter. Finally, the fourth one, it's going in what direction? Negative x, left. So the right side is negative 4ax. The other side's the other letter squared, y squared. So there we go. There's the basic equations. That's the main thing you want to know to be able to do these parabolas. The right side tells the direction. Okay, so let's go to an actual parabola question now. Got that one. There we go. There's number 1. And so they're asking us, there's a parabola. Which of these 4, A, B, C, or D, is the right equation for that parabola? Well, this thing's going up. Up. The direction is positive y, isn't it?
No, it's not C. It's not.
So the right side has to be what? Positive 4ay. You with me? The right side always tells the direction. It's going up. Right side's positive 4ay. What's the other side? The other letter squared, so x squared. So it has to be that basic kind of equation, doesn't it? So it can't be A, and it can't be B, because they have y squared on the left. They're both wrong. So it's either C or D. How do we know which one?
So 1 over 25 is negative 25.
Yeah. Plug in the x and the y to see which equation makes it true. Right? Because if that dot is on the U shape, then it's got to make the equation true. So does it work for C? If I put in, oops, just bumped it there. If I put in 1 for x and 25 for y, is that true? Is 1 squared equal to 25 times 25?
No,
Not even close. It's not C. It must be D. Does it actually work for D? If you put in 1 for x and 25 for y.
Well, isn't that the slope also?
No, there's no slope. Slope's for a straight line. So 1 squared is 1/25 times 25. Is that true?
It is over 1 and up 25.
It is true. 25's canceled.
It really is over 1 and up 25.
Oh, yeah, that's right. You learned. Now, you have to be careful. I know I gave that special rule in algebra. Things are more complex here. That was just a nice little rule that worked for that situation. Yeah, I remember what you're saying. Yeah, but they're going to be more tricky. They put more into it here. So there we go. So D is right. D is right on that. Okay, so number 4, same kind of thing. They're giving me a picture. They want me to find the right equation. Can you do that one? I'm sure you can. So give it a try. Think about the direction first off. Always start with direction. Then write the basic equation. Then you can eliminate 2 of those options. And then plug in the point, 16(1), to find out which of the remaining 2 is correct. So, okay, so it's go. What's the direction?
It's
Positive x. So the right side always tells the direction. So positive 4ax. The other side has to be the other letter, so y squared. So no way B, no way D.
No way A.
It's not C.
It's either A or C, huh?
I think
Good so far? Now let's plug in the x and the y. Let's start with A, see if it works. X is 16. Careful, because they're switching orders in the equation. X is 16, y is 1. Is that true?
No.
Does 1 squared equal 1/16 times 16? It's good. A it is. Good? So get the direction, the right side, and then plug in. All right, let's try number 5. Focus 4, 0, vertex 0, 0. Okay, yeah. So, yeah, vertex is center. That's the word they use for center. So they're telling me a focus. They're telling me a vertex. They want me to, from there, come up with the equation. So you always want to draw these. You always want to draw them because that'll tell you up, down, right, or left and help you know what the basic equation is. So let's start with the vertex, 0, 0. So go ahead and put down the dot that's the focus, and then see if you can draw the general look of the thing. So 4, 0, 1, 2, 3, 4, right there. 4, 0. So which way is this parabola going? Up, down, right, or left?
Right or left?
Remember, this is the center.
Different one.
Yours is going left. Huh? And this is going to the right. Because remember, the focus point is always inside the satellite dish. It's always inside. So it always goes towards its focus point. Okay. So now what's the basic equation? So the direction is positive x. So the right side is
4ax.
positive 4ax. The other side's the other letter, so it's going to be y squared. Good. And now, when they're going to say the words, find the equation. Do you know what they mean in math? They're not very clear when they say that. When they say find the equation, they mean the only letters left are x and y. That's what they mean. They mean get rid of all the other letters except for x and y. That's what they always mean in math. Any situation, not just here, but all situations when they say find the equation. They mean, hey, get rid of all the other letters. We only leave x and y. So what letter does that mean I need to find? A, which is the only other letter, huh? So I got it. So basically they're saying, hey, find A.
Isn't that 4?
And that's just 4, right? Because, let me write for you really quickly. You're totally right. A is, I wrote it up here too. A is the distance from the center to the focus point. So notice A is a distance. I'm saying distance because I want you to be clear that it's always positive, right? Whenever nobody says distances are negative, right? If I drove down to L.A., I wouldn't say I drove negative 200 because it was south. Nobody talks that way, right? Distances, you always give positive. So that's what we mean when we say A is a distance. A is a positive number always, whichever way it's going. Right, left, up, or down, doesn't matter. So yeah, A is 4. A is the distance from the center to the focus. It's 4. So plug in 4. So this equation then becomes y squared is 4 times 4 times x. Y squared is 16x. We good there? So there's the equation. I'm sure that answer is an option on that one. Now, last thing, there is one more thing. They're going to ask us to find what are called the lattice rectum points. So let me write that somewhere, right here. Lattice, well, there's no room there. Over here. So lattice rectums. It sounds, I think it's Latin. It sounds like we're in medical school, doesn't it? Mm-hmm. The lattice rectum points. What they are is they're at the focal depth double A distance to the curve. They're at the focal depth double A's distance to the curve. That's probably not super clear.
8?
Yeah. So what I mean is you jump to the focus, which is 4, right? If you go from the center, you jump to the focus, which is 4, and then at that point, you go up 8 and down 8. Those 2 dots you get are the lattice rectum points.
Okay.
Yeah. They tell you, they basically tell you how wide the mouth opens. It's a quick, easy way to get the width of the mouth of the opening of the parabola. So this would be, so they want the actual coordinates then. So what are the coordinates of this point? Over 4, down 8. And what are the coordinates of this point? Over 4, up 8. Again, it's at the focal depth, right? You see how these are all on the same line? At the depth of the focus. So it's at the focal depth. You jump to the focus, but then double that up and down.
Oh, double it.
Yeah, it's always double. It's double A. Like double A batteries, but it's not. Double A. Those are called lattice rectum points, and we're done. We good there? They'll ask you for the upper, 4, 8. The upper lattice rectum, 4, 8, and the lower lattice rectum, 4, negative 8.
I hate parabolas.
And the equation. So let's start by finding the equation, and then find the lattice rectum points. So give that a try. So it's different. They're trying to give you different looks here, different kinds of information.
What is the Directrix line?
Yeah, the Directrix line is that line that's behind.
Oh, okay.
It's always, the Directrix line is always behind the parabola, and it's the same distance away as the focus. So we'll put the focus on there.
Have you been putting this stuff in the video that you put on the board?
Yeah.
Okay.
Yeah, it's all in there. Over 0, down 5. There we go. So there's our focus point.
So how do we know the center is at 0, 0?
Good question. The Directrix line is up at 5. 1, 2, 3, 4, 5. Everybody good with the Directrix line? It's a line that shoots right. Why is it up there? Because this is the y-axis. It has to go right through the y-axis at 5, huh? That's what it says. Y is 5. It hits the y-axis at 5. Yeah, now which way is the parabola going to go? It always goes towards its focus. So it's going to go down.
Yeah, but from where?
But if it has to be the same distance. The
Right.
line has to be the same distance from the focal point, so you know it's right in the center.
It's right in the middle. Remember back here when we did the derivation? I know I told you not to pay too much attention, but maybe you paid a little attention. Remember we started off with that dot and it was what? Right in the center, remember? It was right in the center of the Directrix line. It was the parabola is all dots that are same distance. So right in the middle, huh? The focus point and the Directrix line. So the center is right in the center of the Directrix line behind it and the focal point in front of it. So it's got to be that way. Okay. Can you come up with the equation now? So write the equation of that thing once you have the picture. So remember the direction. Use that to help you write the equation.
Is A going to be negative 5?
Remember, A is a distance, so it's always positive.
Positive.
Yeah, just let A always be positive. So, okay, so which direction is this parabola going?
Negative.
Negative what? Down. Negative what? So the right side is always the direction, huh? So negative 4AY. Down. We good? The other side has to be the other letter, so it's x squared. Good so far? Now, well, they want the equation, which means they want A. They want x and y to be the only remaining letters. So they always meet them out and they say, find the equation. Get rid of all the other letters, just x and y left, please. So how do I find A? What's A?
Negative 5.
Yeah, A is the distance from the center to the focus.
So it's 20.
So it's 5. A is always positive. It's a distance. So put in 5 there. So it's x squared is minus 4 times 5 times y. X squared is minus 20y. We good? There's the equation. Last thing, they want the lattice rectum points. Can you find the lattice rectum points? Find the actual coordinates of the two lattice rectum points. Can we do that?
10 and negative 14?
So you go to the focus point, and then you... Whoop, I'm scribbling all over the thing here.
Is it going to be negative 10?
So go to the focus point, and then double that distance right and left, huh? So you jump out to the focus point, which is 5, then you go 10 this way, and 10 that way. Does that make sense? That's how you always find the lattice rectum points. They're always at the focal depth, but double the distance. So this must be the point over 10, down 5, and this must be the point back 10, down 5. There's the two lattice rectum points. We good? Questions on that? And that's everything they want. Okay, same thing. They want the equation, they want the lattice rectum, they want the picture. So they're giving you different kinds of information now.
I get mine.
Only thing I didn't put in the video was the swirly circles. Those aren't really important. It's just saying there's different kinds of curvature.
So it's going to be even on either side of the x-axis.
Mm-hmm. Mm-hmm.
Axis of symmetry.
Mm-hmm. It's going to be... Yeah.
And 2, 6 is a point on the edge of the curve, right? That's what it means when they tell you a point on a graph, right? 2, 6 is on the curve. So let me jump in with you. So we know 0, 0, this vertex means center, right? Center is 0, 0. And now if I do 2, 6, 2, 6, I'm going to go 1, 2, and 1, 2, 3, 4, 5, 6. So right there, there's the dot 2, 6. So we know the center is the origin. As I said, vertex is 0, 0. And 2, 6 is a point. Okay, so what does that mean? Well, actually, it could go two ways right now. I haven't looked at this yet. But it could go up, like that. Or it could go right, like that. How do you know, right? See, both of them hit the point 2, 6, don't they?
The axis of symmetry is the x-axis.
Yeah, the x-axis goes through, symmetry means same, goes through the middle of it.
Yeah, so it's going to be sideways.
So it's sideways. It goes to the right, not up, right? Because this x-axis is the line through the middle. That's why they told us that. Otherwise, we wouldn't know up or right. Everybody good? So now, can you come up with the equation? So now write the equation. Find the focus and the lattice rectum points. Rebecca?
So I'm not sure how to think about how to find the focus because I know it has to be the same distance from all the points,
Well,
right?
that 2, 6 is not necessarily any special point at all. In fact, it's not. Yeah, 2, 6 is not a lattice rectum point.
Okay.
It's just any old point.
I thought every point on that line, no, not a lattice rectum, but I thought every point on that line had to be the same distance from the focus point.
From the focus point as it is from the directrix line.
Right. Oh, from the
We don't even have the directrix line showing.
Okay, then I don't know.
So, okay, so first off, just start with the direction. Which way is this thing going? Positive x direction. To the right, huh? To the right. So that means the right side is positive 4ax. Start there. And the other side's got to be the other letter, y squared. Good. Now, yeah, we got to find a, don't we? To find the equation means find a. How are we going to find a?
It's 3. Half of that point, isn't that your lattice point?
No, that 2, 6 is not the lattice rectum. So in other words, you might say, well, the focus is just right here too. No, it's actually not. That is not the lattice rectum point. It's just any old point on the graph. They just said point.
The 6 distance though is the same as 3.
So what can we do whenever we have a point on any graph? What does that mean about the equation? Plug it in. Right? 2, 6 is on the edge of the graph. That means if you put in x is 2 and y is 6, it's got to make the equation true. That's the membership requirement on how you get on any graph, right? You make its equation true. So if 2, 6 is on the graph, if I put in 2 for x and 6 for y, what do I get? 6 squared is 4a times 2. 36 is 8a. Can I solve for a? Divide by 8. 4.5. A is 4.5. 4.5. So now we have the equation. What's the equation? It's y squared. Bring it on down to here. It's y squared is 4ax. What's a? 4.5. What is that? 18x. So there's the equation. Y squared is 18x. Everybody good with that? Well, no, we have one more thing. We've got to find the lattice rectum. Everybody see how I found the equation? I found A by plugging in the point, huh? Whenever you have a point on any graph, you can plug it in, makes the equation true. So now find the lattice rectum points. Remember where they're at. You jump out to the focus. Now we know where the focus is, 4.5. That's A, right? Jump out to the focus and then double that to the edges of the graph for the lattice rectum points. So 1, 2, 3, 4, 5. Here's 1, 2, 3, 4, 5. So the focus is right here at 4.5, isn't it?
Twice that is 9.
Yep. Twice of $4.50 is $9. So up 9, down 9. Is that good? So here's lattice rectum. Here's lattice. This is what? Over 4.5, down 9. This one right here is over 4.5, up 9. There's the two lattice rectum points.
So it should almost make like a straight line.
Oh, yeah, for sure. That's what I meant when I said it's at the focal depth. Exactly. Yeah, you could do a straight line right here. That's a good observation. Right here, the focus and the two lattice rectum are all in a straight line. They're at the same depth. The lattice rectum are at the focus's depth. Exactly. Just double the distance away. Is that one okay? Good with that?
It's going to be, oh yeah, positive 4.5 for both.
Yeah, because it's over 4.5,
Yeah.
up 9, down 9. Yeah, good. All right. In the equation, it'll be opposite next to x and y. In the equation, it'll be opposite next to x and y. So, in other words, if x is 3 and y is 2, what you'll see in the equation, this one's going to the right, positive x. So you would see positive 4ax, and this side would be y squared. But what it would actually be is y minus 2 squared and x minus 3. See how that's the opposite from the regular 3 and the regular 2? That's the deal. From center to equation, it's opposite of what's next to x and y in the equation. So in other words, if there had been a negative 3 next to x, negative 3 is the center for x, this would have been a plus 3 in the equation. It's always opposite signs from center to equation. All right, let's get to it. So does everybody get that down? So that'll be this whole chapter. You'll just see that all the time. Whatever the center of whatever shape you're looking at is, in the equation, it's opposite in the equation for x and y. So here we go. So what's this? Here's the center they're giving me. That's the vertex. The center's not at the origin, right? We've moved it. So when you move these shapes off the origin, their center is no longer 0, 0. How does that affect the equation? What happens to the equation? You put the opposite of x and the opposite of y. So the opposite of the x4 and the opposite of the y negative 5. So we should see x minus 4 and y plus 5 in the true equation, shouldn't we? So we can narrow it down to 4 options. That's not a lot, but D and E both have x minus 4, y plus 5, and G and H. It's one of those 4. Those 4 out of 8, I guess we've eliminated half of them. Those 4 all have x minus 4 and y plus 5, which has got to be the case.
But the way that it's oriented on the graph says it's negative 4ax.
Good job, good job. Now we say, which way is it going? It's going left, which is the negative x direction. So the right side has to be negative 4a and the x, which is x minus 4. So the right side has to be that. So E it is. Because of the direction, negative x direction. We good? Not too bad? So just opposite. So whatever the center is, in the equation, it's opposite x, opposite y. Always. Try. Look at they're giving you the center 2, 6. So you know what that means about the equation. Okay, so in the equation, it's going to be, first of all, which direction is it going? How about we do that? What direction? Down, that's negative y, so the right side's got to be minus 4ay, the other side's x squared. But it's not x squared, we got a 2 there for x, so it's going to be x minus 2 squared. The right side's got to be, what do you got? A 6 for y minus 6, huh? So minus 4 times y minus 6, is it d? Is there another one that does that? It's got to be d. Now you might wonder, well, where's the a? Yeah, they figured out the a is 1. I don't know how they did, but we don't care. We know it's got to be d. Nothing else fits it. Good for now? We'll keep going. You're good. Do you like puzzles?
No.
Number 8. Vertex negative 4, 6. Focus negative 3, 6. Let me write that over here. So vertex negative 4, 6. And what's it called? Focus negative 3, 6. Negative 3, 6. Okay, so I would encourage you to draw a graph here. Let's draw a graph. And let's put the vertex means center, doesn't it? This means center. Put the center point on the graph, negative 4, 6. And put the focus there as well. And then see if you can write the equation. So back 4, 6, that's the center. And then back 3, 6 right here. That's the focus point, huh? We good there? So I got the center dot and the focus dot. The vertex and the focus. So which way, remember you start at the center, go towards the focus. So which way is this parabola going? To the right, huh? It's going like this. You good? Because you start at the center, go towards the focus. So, can you write the equation now? Mm-hmm. Based on the direction and the center. Remember to put the opposite next to x and y for the center. Because the center is not 0, 0 anymore. So when I write the equation, so the direction is the positive x direction, so the right side will be positive 4ax, positive x direction, the other side is y squared. But I have to put the adjustments in, because that would be the equation if it was centered at the origin, centered at 0, 0. But in reality, this is the x, this is the y of the vertex, the center. So it's y minus 6 squared 4ax plus 4, huh? Opposite for x and y. We good there? One more thing. We need a. So they want the actual equation now. So we need to find a. How can we find a? What is a? It's the jump, the distance from the center to the focus point. How far is that? 1. A is 1. So this is y minus 6 squared is 4 times 1, or just 4. X plus 4. There's the equation. See how we did that? Feel like you can put this puzzle together?
No.
Enough clues there? It's like a little mystery. Come on back. So what is it we're looking for? Y minus 6 squared. equals 4x plus 4. B, yeah. B. Now it's saying, what are the coordinates of the 2 lattice rectum? Yeah, so this gets a little harder. Because now everything's like shifted and moved. You got to be careful. Can you find, let me do it with you. Let me find the lattice rectum. Okay, so how do we find lattice rectum? What's the rule?
You plug in the point.
You jump to the focus and then double that to the edges of the parabola. Right. So it's a jump from the center to the focus is 1. So then I'm going to go up 2 and down 2. Down 2 and up 2. Right? So far so good? But up 2 and down 2 from what? From the focus. So you've got to take the focus's coordinates. Here, let me do that. So the focus point is -3, 6. So the focus point is -3, 6. So, right?
7.
That's him. And I'm going to add 2 and subtract 2 from his y coordinate. Why? Because I'm going up and down. That's y coordinate, huh? Everybody good there? I'm adding 2 and subtracting 2 to the y coordinate. So that'll be -3, 8 and -3, 4. Those are the two. That are those 2 dots right there. This one's -3, 4. The other one's -3, 8. I still have room to put it in there. See how I found those? I took, so the key there is I took, because now we're not going from the origin or from anything on a 0 anywhere. So you got to take whatever jumping off point, the focus point, and add and subtract to his y coordinate. Now if the graph went the other way, you might have to add and subtract to the x coordinate. We'll see examples of that. Ours was clearly going up 2 and down 2, so y coordinate, right? Good there? So we found the lattice rectum. I think that's all they want. Then they want the graph, which we already got. So -6, -2 is the focus. And the directrix line goes through the x-axis, straight through the x-axis at 6. So 1, 2.
That means it's directly behind the bottom of the parabola.
So there's the directrix line. Yeah, the directrix line is behind the parabola, and the focus point is inside the parabola. So you got to find the center there, huh? This is over 6. That's 6. So where's the center going to be?
0, 0. Or 0, -2.
It's going to be right here, isn't it? That's the center. At over 0, down 2. That's the center.
That's
Or the vertex. Because that's right in the middle, huh? Yeah, because it's 6 that way and it's 6 that way, isn't it? The center's got to be right in the center of the directrix line and the focal point. Everybody see that? So that's got to be the center. It's directly in the middle of the focus point and the directrix line.
So we know the vertex. Okay.
And then which way is this thing going?
Negative.
Going left.
Negative x.
So that'd be the -x direction. All right, so it's going in the -x direction, left. So that means the right side is -4x. So remember, the right side always tells the direction. -x, right side -4x, other side's the other letter y squared. But we got to put adjustments in. It's going to be y plus 2 and x minus 0, but that's just x, huh? You guys with me? So everybody good? You had to put the adjustment for the y plus 2. Now, we still need a. Everybody good so far? What is a again? It is the distance. So how far is it
6.
from the center to that? It's 6. And it's always positive because the distance. So we put in 6 right there. So it's going to be y plus 2 squared is minus 24x. Huh? 4 times 6? The A is 6. So there's our equation. And, of course, they want what they always want, the lattice rectum points. Can you find now the 2 lattice rectum points? So remember to use the coordinates of the focus point because you jump off from the focus point, don't you?
You have to.
Okay, so yeah, so to find lattice rectum, right, we jump to the focus point, which is 6 away, and then up double, up 12, right, add 12, down 12. We good to the 2 lattice rectum? It's always double the A. The A is 6.
Right, okay.
Right? It's always double. I remember I made a joke about double A batteries, kind of dumb. But help you remember. Double A. So 6, 12, 12. Right? You always jump to the focus, then double, double to the last right. Now, so that means I got to add 12 and subtract 12 to what? What am I jumping from? This focus point. So you add, the y value. Add 12 and subtract 12 from the y value again. So if you add 12, what do you get? Minus 6, what, 10? And if you subtract 12, what do you get? Minus 6, minus 14. There are the 2 lattice, right? This one is minus 6 up 10. This one is minus 6 down 14. The 2 lattice rectum points. Getting the hang of this? Next time we're going to do some word problems, actual satellite dishes and bridges. The rest of this section is more applications of these things.